Welcome pre-calculus students. This is the second video about circular functions. So we are going to look at different format of the problems where you have to evaluate cosine of pi minus theta, cosine of pi plus theta, and basically these are the translated version of the normal sine and cosine. So this document is posted in the module. This document is in the module. I highly recommend that you take a look at this. I'm only explaining a couple of questions here. There is a independent practice problems for this on the other side. So you have to get this document, access it from the module. So let's take a look at the direction. It says use of unit circle to find the trig functions theta plus minus pi, theta plus minus 2 pi. So normally we know the normal theta. But what happens if we add subtract 2 pi? Which quadrant it will end up in? So we are going to look at the two examples today. First one is what happens if you are given your theta in first quadrant. So these numbers are not relevant to, you can still work on this. Does not matter what these numbers are, they are just telling you some ratios. So you can see x and y, they both are in a first quadrant. So I can make some connection that this is my point P, and the circle we are going to use as an aid to see the transformation. So let's take a look at this. So this is my first quadrant, 1/2. First quadrant is 1/2 x. No, x is not 1/2. Sorry, sine comes. Cosine is so 1/2 on this right, and √3/2. √3/2. So this is I'm sorry, my graph is not very accurate. So let's make it 1/2 is somewhere here. That's a little bit better. Coordinates are 1/2 and √3/2. So this is angle theta. What will be cotangent theta, tangent theta, cosecant theta, secant theta? So these four questions should be straightforward. We know that the secant theta is reciprocal of cosine, so 2/1. Cosecant theta is reciprocal of sine, so 2/√3. Tangent theta is y/x, which means my y coordinate is √3/2/1/2. You have to simplify, and this number is √3. Cotangent theta is reciprocal of tangent theta, and I can say this is 1/√3. So these four answers are pretty straightforward to answer. These are the one you have to make some connection that theta is here. What is pi minus theta? And for that part, you have to make some connection that this is a pi, this is a 2 pi. If this is my angle theta, so my reflected angle will be here on the second quadrant. I'm just reflecting all of them so that we can see. And this angle, we call it pi minus theta. So pi minus theta is in a second quadrant. So this is, I'm just writing that my answer is in a second quadrant. Third quadrant, these coordinates will be, both of them will be negative. So I'm just writing that the both are negative, and this will be pi plus theta. So pi plus theta, my point is going to be in a third quadrant. Pi minus theta, we got it. That's my point is in a second quadrant. Okay, so let's take a look at the theta plus 2 pi minus theta. So we know the periodicity that 2 pi plus theta, which is the same as sine theta, because you are making a one complete circle and you are coming back at the same point. So this is my same point in a first quadrant, my original point. Now this point in a fourth quadrant where I have x positive, y negative, this is my original one. So I'm just putting this is my original one. We are reflecting in a few different quadrants, but our understanding is based on pi minus, pi plus. So this is a 2 pi, and I can say that if fourth quadrant reflection will be 2 pi minus theta. So 2 pi minus theta will be that fourth quadrant. That means this is my location. This is the transformation where my graph would be reflected, not the transformation, but the reflected. Tangent pi minus theta, that means I'm back in the second quadrant. So all you have to do is read the coordinates. Once you have those transformation here, and once you identify the location, all you have to do is read the coordinates. Second quadrant, cosine, sine, cosine, sine, cosine, sine, cosine, sine. So what's the cosine pi minus theta in a second quadrant, which is -1/2? What is cosine pi plus theta? Pi plus theta, second quadrant, cosine is negative. So I will say this is -1/2. Sine pi minus theta, which means back in a second quadrant, that's √3/2. Sine theta, same original one, that's also √3/2. 2 pi minus theta, which will be my fourth quadrant, and cosine, which is the same x value we share, and 1/2. Tangent pi minus theta will be second quadrant. Tangent is the ratio of these two, and we can say that will be -√3. If you take the ratio of y over x, the two get cancelled, and that will be -√3. Oh, we have one more. So tangent of pi plus theta, this will be the ratio of two negative number, third quadrant. Tangent is positive, remember all STC. So this answer is a √3. So please pause the video here and check your answers again one more time. Before we jump on to the another quadrant, I would like you to review one more time this basic one where the point is given in a first quadrant, then this pi minus, pi plus, 2 pi minus theta works. But what happens if you are given a point which is not in a first quadrant? Then how do you consider that pi plus, pi minus, 2 pi plus? So let's take a look at another function here. Another quadrant, not a function, but very similar scenarios. So you are given a cosine theta is negative. You are given cosine theta is negative. Sine theta is positive. So think about x is negative, y is positive. Which quadrant would be? Your original point is x is in a negative, x value is negative, y value is positive. So second quadrant, so pick any point. The previous example was the unit circle angle. Here, these are not the special angles. You do not need to find angle theta based on negative, positive. All we are saying that this is -12/13 and this is 5/13. This is x, that's y, this is cosine, this is sine. Okay. Your original point is in a second quadrant. So your theta is somewhere in a second quadrant. So let's pretend that theta is some angle in second quadrant. Theta is, pick any number just for the evaluation. We are just trying to find out where the transformation or reflection will be. So let's say theta is, pick an easy number in a second quadrant. I would say 100 degree. Let's say theta is 100. We don't really need to find the angle theta. You can say theta is 100 or any number in second quadrant. Any angle in a second quadrant. We know that this is 90 and this is 180. Now we know that we always prefer radians, but here it would be a little bit easier if we work in degrees because it's easy to add, subtract. So let's find this easy three of them first. Secant, cosecant, tangent. Tangent is a y over x. So 13 over 5 over 13, sorry. 5 over 13 over negative 12 over 13, which is negative 5 over 12. Cosecant theta is reflecting, secant is reflection of cosine, negative 12. Cosecant is reflection, a reciprocal of sine. Sorry, not reflection, but the reciprocal. Okay, so now this 3 was easy. How do we find the other, this 6? Pi plus, pi minus, where am I? So always think of that. Pi is 180. Pi is 180. If you add 180, you end up exactly opposite. This is opposite of 100, and you are adding basically half circle. Your original point is in a second quadrant. Pi plus 180, you are going in the opposite direction, which will be my fourth quadrant. So identify the location first. Where am I? In other words, you can also say that the pi is 180. So 180 plus 100. 180 plus 100, which is somewhere 280. So that's my fourth quadrant. 280, that's my fourth quadrant. Okay, theta plus 2 pi. We know that theta plus 2 pi, which means I'm back to the original place where I was. Period of sine, cosine is a 2 pi. That means I'm back in the original place. This is my original place. So I'm back in a second quadrant. That's my original theta was in a second quadrant. Okay, so now these are interesting. Pi minus and 2 pi minus. So remember we said pi is 180, theta is 100. So what will be this? 180 minus 100. Just mentally make connection. 180 minus 100 is 80 degree. And 80 degree is in a first quadrant. So that's my location, first quadrant. Which means my reflection of this is going to be in a first quadrant. 2 pi is a 360, and remember theta is 100. So 360 minus 100 is 260 degree. We know that this is 270, so 260 is my third quadrant. Now we found all the locations. Now answering the question is nothing but the reflection of this point. If I reflect this point in a first quadrant, I know that the both will be positive. The same numbers, this will be 12 over 13, this will be 5 over 13. If I reflect in a fourth quadrant, it will be 12 over 13, negative 5 over 13. Third quadrant will be, they both negative, and we know that first is a cosine, second is a sine. Cosine, sine, cosine, sine, cosine, sine. So let's read the numbers. Fourth quadrant cosine, what's that answer? 12 over 13. Second quadrant sine is 5 over 13. Fourth quadrant here, the fourth quadrant tangent. Tangent is, we can use this number also, and we know that the second and fourth tangent is negative. So negative 5 over 12. First quadrant, everybody positive, the same answer, but it's a positive. Sine is already positive. First and second quadrant, sine is always positive. And the third quadrant is negative. So make sure you understand this. The concept here is identify the original one first, and then pick any angle in the theta, any angle theta in that appropriate quadrant. This is my original point, and then based on reflection, you have to identify the location, write the locations. Once you write the location, all you have to do is read the number. Okay, prepare to ask any question in the class, and you may come for student focus student intervention as well. Now for your extra practice, there are questions on the other side. You should try this C and D on your own. C is the point given in a third quadrant, you can see that, and the D is the point given in a fourth quadrant. So why don't you try this on your own for extra practice? Prepare to give an assessment on this kind of questions in class. Thank you.